When you think about proportions, you might think about something like this. I need 1 1/4 cups of flour to make 30 cookies. How much do I need if I want to make 80 cookies? Which really, you can never have enough cookies. So it's an important question. We can solve this. We experienced algebra students can solve this by setting up a proportion. It might look something like this. I need 1 1/4 cups of flour for 30 cookies. And I don't know how much flour for 80 cookies. And even though I don't know how much flour, I know that the proportions have to be the same in baking or it'll come out weird. So that's where we start from. And then we, again, as experienced algebra students, say, okay, we're going to cross multiply the top of one fraction by the bottom of the other one. So I have 1 1/4 times 80. That was supposed to be a 4. We'll just pretend it is. That is not supposed to be a 4. That's supposed to be 0. 80 cookies. And the other way, 30 times, I don't know how much flour. Then I'm going to actually multiply 1 1/4 times 80 is 100. And then, sticking with the algebra theme, I'm going to divide both sides by 30. Isolate the x, the algebra catchphrase there, and I'm going to need 10/3, which I don't have a 10/3 cup measuring cup, so we'll change it to a mixed number. That's 3 1/3. I'm one ahead of myself. 3 1/3 cups of flour. And we're there. If we're talking about elementary school students, though, which we are, this might be a little bit beyond their scope. It would be a 6th or 7th grader who's comfortable with fractions, might be able to work it out. But if we can still talk about proportions even with younger children if we approach it more intuitively. Something like, if I can walk 1 mile in 20 minutes, which I can go faster than that on a good day. Then we can say, well, how long will it take to go 2 miles? We can even set up a little table. And hopefully the kid's going to say, well, 2 miles, 20 minutes and 20 more minutes, that's 40. How long will it take me to go 3 miles? Well, that's 20 more minutes, which is 60. And then hopefully we can lead them on and say, well, how long would it take me to go 10 miles? Well, 20 minutes for each mile. 10 times 20 is 200 minutes, and then we can have a conversation about, well, how long is that? Because when I see 200 minutes, I don't necessarily know how much time that is, so we can talk about converting minutes into hours, something that's a little bit more useful. Then if we have that down, maybe we can say something like half a mile on a map, or sorry, half an inch on a map, half a mile on a map, that's a really big map, is 10 miles in real life. So then how far in real life is, say, 3 inches? You certainly could do this using a proportion, but we can also do it not. You might have kids that say, okay, maybe we're even counting on our fingers how many half inches are in 3 inches. We'll come up with 6. So that's 6 groups of 10 miles, which is 60. Maybe, if you're lucky, you'll have somebody that says, well, I don't really like half an inch as a measurement. If half an inch is 10 miles, that means 1 inch is 20, which means 3 inches is 60 miles in real life.